Hello, and welcome to this very first lecture of the course Microeconomics Industrial Organization. And as was announced, and as you are clearly noticing by now, this lecture will be delivered on video. Okay, so this is what I'm going to do today. So we'll start with an introduction to the course. I will tell you a bit more about the organization of the course. And then there are a couple of topics that are also part of the first week of this course. And note that weeks run from Wednesday to Tuesday in this course. So be aware and be prepared that your very first tutorial may already take place Monday morning at 9 o'clock. Okay, so let's first do an introduction to the course content. So this goes back to your first year microeconomics, where we sort of studied consumers, firms, but we also assumed that everything was perfect, that markets were perfectly competitive, at least for most of the course, which implied that prices equaled marginal cost, and we noted that that is the socially optimal outcome. Um, But we also noticed in this course that in the real world, firms, of course, often have market power. There is no perfect competition, but in many industries, there are a couple or sometimes just even one firm active, and that drives a wedge between price and marginal cost. Market power simply means that firms are able to set a price higher than marginal cost. And as we already saw in the first year course, that deals a deadweight welfare loss. So in this course, we go into more detail into those things. We already studied the case of a monopoly in Micro 1, but we will now study the case of competition between a number of firms. And that's pretty tricky because, of course, these firms are all reasonably sized, so they do take each other's action into account. They're not just price takers. In Micro 1, we sort of covered the two extremes of the spectrum. So we either had just one firm. If you are just one firm, you don't have to take your competitors into account simply because you don't have any. And the other extreme was a monopoly. Sorry, the other extreme was perfect competition, where you don't have to take your competitors into account simply because they cannot affect the market, and neither can you, essentially. Okay. Brings us to the name of this course, industrial organization. So what is industrial organization? Well, first of all, it is, as most of microeconomics, concerned with the workings of markets and industries, and in particular with the way that firms compete with each other. It studies the economics of imperfect competition. So these are essentially just three ways to explain the same thing. And that implies that we study strategies of firms to the extent that is not offered in Micro 1. So we not only look at firms that set prices, but we also look at other possible strategies like R&D, advertising, forming cartels, you name it. And also following up on Micro 1, to do that, we use models. So models are simply simplified representations of reality that focus on the aspects of reality that are important for the problem at hand. So we will often assume away anything that is not relevant for our problem. So you can think of this, well, like a road map. If you want to go somewhere and you use your Google Maps or whatever, that map is highly stylized because if it is too detailed, if it has all the details of all the buildings along the way, then the map is no longer useful. And also, we will focus pretty much on strategy. So it's the strategy of firms, and if you choose your strategy, you may want to take into account how other firms will react to that or what other firms will do. And that means that we will often use game theory, but more on that later. So, first of all, I talked about market power already. So, how much of an issue is that anyway? First of all, back to the definition that I already gave. Well, market power is essentially the extent to which firms charge prices above marginal costs, right? Or the extent to which firms are able to do it. Has been a hot topic in recent academic literature and also in policy discussions. So if you read the newspaper, then you can see that we are often increasingly concerned about market power. Politicians are increasingly observed, for example, in the discussion in the Netherlands on interest rates or prices in supermarkets, but also issues related to big tech. For example, do large platforms like Google or Amazon have too much power? If so, what should we do about this, etc. So to sort of justify that whole discussion and also justify why we study these issues, let's take a look at the average markups in the US economy. So what is the markup? Markup in this context is simply the price divided by marginal cost. So, or rather the price cost margin divided by marginal cost. Depends a little bit. So if markets are perfectly competitive, prices would equal marginal cost. But if there is market power, then the more market power, the more the discrepancy between prices and marginal costs, right? Okay, so here's a graph from a recent paper. So this really looks at the ratio of price and marginal cost. So if this is one, we have perfect competition. If it's higher, well, the higher it is, the more market power we have. So here you can find the source of this study. So this is a couple of years ago, but it spawns a big literature um, related to this issue. So here you see that price cost ratio actually through time. So it used to be sort of stable at around 1.3, fluctuating around that a little bit, but starting in the mid 80s, sort of the ratio went up and stayed stable around 1.45 in the early 2000s, but since 2010 it has increased again. So this graph suggests that yes, indeed, market power is a problem since it seems that firms are increasingly able to set prices above marginal cost. So there's a whole literature on this and how we should interpret this and what are the possible explanations and also whether this is measured correctly. But let's not go into that here. So that was the US. What about the rest of the world? Well, the rest of the world, a pretty similar picture to the US, right? Things went up, especially starting in the 2010s. And here you can look also at your favorite area of the world. So again, similar pictures anywhere. South America is a bit different, but especially Europe, North America, Asia, Oceania, not in Africa, but in those other continents, we do see a similar picture. Market power really picking up, especially over the last 1.5 decade. Here are a couple of individual countries you can in the EU, so you can pick your own. The Netherlands seems actually pretty stable, but of course, in the Netherlands, we also consume a lot of stuff from outside the Netherlands. Denmark is pretty dramatic for some reason. Well, if you want to know more about these details, then you can check the source. So, yeah, indeed, a very important question is, of course, what causes these increases in markups, right? So, it could be that industries have become more concentrated, which gives them more market power and more leeway to increase prices. But yeah, to sort of measure that, to evaluate whether that really is the reason, we first need some measure for concentration, right? Um, so there are a couple that are commonly used. So first of all, we have the concentration ratio of an industry. CR4 gives you the combined market share of the four largest firms in an industry. So mathematically, that looks like this. So if SI is the market share of firm I, and you order all firms from largest to smallest, then if you take the sum of the market share of the four biggest firms, you get your CR4. So that would be one way to measure how concentrated an industry is, right? If your CR4 is higher, then at least the biggest four firms have increased in size, and that suggests that those firms may be able to set higher prices. Uh, but at the same time, that measure is also a bit crude. It also only looks at the four largest firms, and it doesn't look at how those four firms compare. Maybe there's one really big one, whereas the other three are pretty small, etc. So it would be nice to have a measure that takes that into account as well. And a very good measure, a very useful measure, is the Herfindahl-Hirschman index, sometimes just referred to as the Herfindahl index, of an industry. So what does that do? There you simply take the sum of the squares of the market shares of all firms in the industry. So that looks like this. You take the market share of the biggest firm, you square it, then you take the market share of the second biggest firm, you square it, etc. And that gives you a number that reflects how concentrated that industry is. Um, there will be an exercise in the tutorial this week that allows you to play around with that. But good thing to note is that, well, if there's just one big firm, if there's a monopoly, then that firm has market share one. And all the other firms have market share zero. So then your Herfindahl index will be one. But if you would have perfect competition, then you would have many, many firms, but all firms would have a market share of zero. So you essentially would take the sum of zero squareds many times. So that would give you zero. So that's a very nice scaling as well. If you have perfect competition, your Herfindahl will be zero. If you have a monopoly, it will be one. If it's in between, then it's in between. Um, Slight digression. So this is actually interesting. So Hirschman, Albert O. Hirschman, the guy that gave his name to at least part of the Hirschman-Herfindahl index, uh, also stars in a Netflix series. So on Netflix, you can find the series Transatlantic, which is about a bunch of people in Vichy, France in the 1940s that managed to smuggle quite a few Jewish intellectuals from France to the US. And that group involved actually Hirschman himself. He also fled to the US at the end of the Second World War. Uh, so that is part of the private life of Albert Hirschman. Anyway, back to competition and back to market concentration. So I already gave you two measures of market concentration. So here we have the CR4, one of the measures that I mentioned. This is the CR4 in the four largest European economies. Um, here are different ways of measuring that. But what you can see overall is that in this century, indeed, the CR4, the average CR4 has increased, right? So this picture of increasing market power, or rather increasing ratios of prices to marginal cost that we saw, um, this picture suggests that it indeed may be explained or partially explained by an increase in market concentration. Um, if we look at the Herfindahl index for publicly traded firms in the US, so firms on the stock market, then you can see it's another source that pretty much mirrors the picture we saw earlier, right? The picture of increasing markups. So those increasing markups indeed are consistent with an increase in market concentration, also according to this measure. So the numbers here are the Hershman-Herfindahl index. So I argue that it would be between 0 and 1, but what we usually do is multiply it by 10,000. So that gives rise to these kinds of numbers. Okay. So what did we see? We did see that markups have increased this century, especially over the last decade and a half. And at the same time, industry concentration has also increased. So there is really something going on there, right? So it is crucial to understand the determinants and effects of market power. And that's exactly what we plan to do in this course. So we study how firms compete, how they set prices, how they innovate, how they defend their market power, etc. And also, what are the effects of mergers? What are the effects of price fixing? In the last week, we will also look at platforms, which have indeed also come up in the last 1.5 decades. So, what is their business model and how does competition between, among, but also on platforms work? And of course, we are economists. So at the end of the day, we are concerned about social welfare, which implies that we are concerned about possible government intervention. So there will be a crucial question as well. If things go wrong, then what should government do about it, if anything? And that will also all be part of the next 6.5 weeks in this course. So a bit more detail, in weeks 1 and 2, we will look at price discrimination. So firms often charge different prices to different consumers. Is that a good thing? Why would they do that? Why is that a good business model? In week 4, we will look at when do firms keep potential competitors out of the market? How can they do that? Does that make sense? How can we avoid that firms make agreements to raise prices? That's another concern that we will address in week 5. Mergers are the topic mainly of week 6, and platforms and R&D will be addressed in the last week of this course. Which brings us to the organization of this course. Here's a quick overview. So each week we will have one lecture and we will have one tutorial. Exercises for the tutorial will be on Brightspace before the actual tutorial, and afterwards we will also publish the results, the solutions, and the complete derivations. However, it's very important in this course to practice yourself and practice as much as possible. Only then can you get a feel for the material, see where the problems are, etc. If you just watch us solve the solution on the blackboard, then quite frankly, you won't learn that much since, well, it will all look very easy, but at the exam, there's no one to show you how to do it, so you will have to do it yourself. That also implies that it's a good idea, it's a really good idea to try to do the exercises in advance. And since practicing is so important, we will try something new this year, which will be that after the tutorial, we allow you to practice even more in an optional practical, but more on that later. You're all second year students now, at least, so you should have grown up and you should be responsible, which means that attendance at either the lecture or the tutorials is not compulsory, but if you would like to pass the course, it is a very good idea to go there to both the tutorial and the lecture and even the practical. In terms of grading, there will be a midterm, there will be a final exam. The midterm makes up 30% of your final grade, and the final exam makes up 70% of your final grade. So the midterm allows you to get up to speed at an early stage, already secure part of your grade, but should you mess up, then you can still comfortably pass the course. Um, However, if after the midterm and the exam it turns out that you have failed the course, you will obviously have to do the resit. Uh, for the resit, your midterm and your final exam doesn't count anymore, which also implies that the midterm makes up 100% of your final grade. So either you pass the regular exam, which consists of midterm and final, or you pass the course with the resit, which is the resit on all the material. Uh, so that also implies, by the way, that the midterm, both the midterm and the final exam, take 2 hours, but the final exam, you have to do all material, so that will take 3 hours. Also, the material that is covered in the midterm will not be covered again in the final exam, part of course from the stuff that you also need to do the exercises in the final exam, but more on that later. Also, good to know, the exam will not only cover exercises, we will also ask you about the content of the material, which should be easy because you can just learn that, but somehow people still score very badly on those questions. So do take that into account. If you already did this course last year, then, well, clearly your midterm will also not be valid for this year. You will have to start all over again. Good. So a bit more about the timing. Usually we do the lecture at the start of the week, we do the tutorials at the end of the week, but one problem, one coordination problem, as we like to call it in game theory, is that all courses do that, which means that the big rooms are completely full at the start of the week and the smaller rooms are completely full at the end of the week. Therefore, we have turned things around. Lectures will take place on Wednesday from 3 to 5, and the tutorials on Monday and Tuesday. So over the weekend, you have time to prepare those exercises. And the advantage of that, of course, is also that lectures will be at a decent time. Last year they were at 7 p.m. at night. That's no longer true now, since we now have plenty of space to do that. The first lecture appears as a video. You have probably already figured that out. Um, and do note that, well, your tutorial may already be Monday morning at 9 a.m., so be prepared. Um, okay, if you want to rewind the lecture, that will be possible because the lectures that will be given on Wednesday, they will also appear as a video on Brightspace, YouTube, whatever, shortly after the lecture so that you can watch again the stuff that you haven't understood yet, how to do stuff, etc. At least this is the plan. If for whatever reason the technicalities don't work out, then it may be the case that the video won't appear, but the plan is that we will record the lectures and make them available to you immediately afterwards. Of course, it's still a very good idea to follow the lecture. You can participate in the quizzes. You can discuss with other people. Um, so do come there. Then back to the practical. So this year, as an experiment, so it may change during the course of the course, but we will offer some practicals. What is the idea? Well, you have gone to the lecture, you have prepared your material, you have try to do the exercises from the tutorial at home. Maybe you haven't yet managed to do that. Then you have come to the tutorial. So now you really know how to tackle the questions, but you want to practice some more. Okay, you can come to the practicals, which will be on top of the tutorials. There will be two of them. And there you will receive additional exercises and you can just sit down and try to solve them either alone with the group, whatever you like. But if you do get stuck, we will be around there to help you out and make sure that at the end of the tutorial, at the end of the practical, you really know how to approach the problems. So these practicals take place Tuesdays at 3. So after most of the tutorials, there's still a practical then as well. There's still a tutorial then as well, sorry. So take that into account if you schedule your tutorial. We will not be sure how many people will show up for the practical, so we want you to sign up each week in advance. There will be announcements on Brightspace on that, so we can keep track of who will come and whether we need bigger rooms or whatever. Um, of course, this is experimental. If nobody shows up, then we are likely to cancel them. If really many people show up, we're likely to expand it, but we will see. So things may change. This is the plan for now, but plans can change. Okay, so much on the organization. There's still a book as well, although in the past, some students have argued that you may not really need the book. This is the book. So that's Introduction to Industrial Organization by Cabral. So this is advised but not compulsory literature. And the good news actually is that you can also get an ebook from the library. More details on Brightspace. So if you just want to have a look at the book every now and then, but don't want to buy it, you can just um, get access to it online via the library. The lectures complement the book, which means that not everything in the book will be in the lectures, and not everything in the lectures will be in the book. And formally, they're both part of the exam. And on top of this book, there will be some additional readings in the last week that will be on platforms. Platforms are not covered in the book either, but also those additional readings will be available online. Who will you encounter in this course? Well, first of all, that used to be me some years ago. I do the lectures, I do the coordination. Then there are 3 additional people who do the tutorials and sometimes also the practicals. So this is Simon Elgersma. We have Maximilian Osterhaus, takes care of tutorials and a practical. And we have Nanette, also 2 tutorials and 1 practical. Good. Some very important notes regarding this course. Whenever you send an email to someone, make sure you do it correctly. So this course is called Industrial Organization and not Industrial Organizations. Also, for the Dutch students, my name is Marco Haan. As you may have noticed, it's not Marco de Haan. So take care of that. I usually get annoyed if you call me by the wrong name. For the Asian students among you, there's a different mistake often made with my name. So my name is Marco Haan. It's not Macro Haan, right? After all, I'm doing micro, so it's particularly painful if you approach me as macro. And if you don't comply with these points, it may result in non-reply to your communication. Anyway, Most of you have done the first year course Micro 1. Not all of you have. Is that a problem? Not really, I would say. Essentially, the only thing that you really need from your Micro 1 is consumer surplus, but that's about it. If you like, you can also check the first couple of chapters in Cabral, which also give the Micro 1 background that you need. But apart from that, if you make sure that you understand what consumer surplus is, look in a textbook, look on Wikipedia, look on YouTube, then you should be fine in terms of preliminary knowledge. So, the next topic, let me tell you a bit more about competition policy. Because everything you will learn in this course is applied directly in the real world, in competition policy, antitrust policy around the world. So, a little bit of background on that. I will not go too much into the nitty-gritty details. The book is much more detailed on that and has all the background information that you may need. So I will shortly go into competition policy in the US, in Europe, and the main areas of competition policy. So the main idea is that, well, as a society, we want competition to be effective. We want to avoid that firms abuse their dominant position. And we want to avoid that firms that are supposed to compete with each other start making secret or open agreements on prices or whatever. So that is what competition policy is concerned with. So in the US, these are sort of the main players, the Department of Justice, the Federal Trade Commission, there are some sectoral regulations, and these organizations try to monitor competition and make sure that actions are taken if somebody doesn't stick to the rules or if mergers lead to firms that are too big, essentially. So these are sort of the legal background of competition policy in the US. So in the US, we have the Sherman Act that started in the 1890s. So back then, a lot of companies, a lot of industries were organized as trusts. So we had the Sugar Trust and the Oil Trust and what have you. And that's also the reason that competition policy is often referred to as antitrust in the US. And the Sherman Act covers horizontal and vertical agreements between firms. I will definitely go into that much more in the remainder of this course, and also abuse of dominant position. So if you have a dominant position, if you are a monopoly, for example, you are not allowed to abuse that position. There are a couple of other laws as well. There's the Clayton Act and the FTC Act. Again, more details in the book. Let me not go into that in too much detail. Europe is also interesting. So in Europe, we have DG Comp, part of the European Commission. So that is sort of the antitrust authority, the competition policy authority in the European Union. And then we have the national competition authorities as well. So in the Netherlands, that's ACM, the Authority Competition and Market for Consumers and Markets. And so essentially, whenever there are antitrust concerns within the Netherlands, in that case, that is covered by ACM. But if there are international implications within the EU, then the European Commission takes care of that. This is the legal background of competition policy in Europe, and that is roughly along the same lines as in the US, with a lot of nitty-gritty details that are different, of course. So this is since last year, the European Commissioner for Competition. So Teresa Rivera from Spain is currently in charge of competition. policy enforcement in the European Union, or technically, she's vice president of the European Commission and the Commissioner for Clean, Just, and Competitive Transition. And we are in this course mainly interested in the competitive part of that, of course. Couple of key differences between the EU and the US. So in the US, criminal law is also involved. So if you form a cartel, then in the US, you can actually go to jail for that. The common market, so free competition between the member states is an important element of competition policy in the EU. In the US, if you are hurt by a firm that is not competing fairly. So, for example, if you are suffering from a cartel, then you can actually claim treble damages. So, whenever prices are too high because there is a cartel, for example, you can sue for 3 times the amount of your disadvantage. If you are interested in these things, then definitely finish your bachelor and take our master course competition policy in the master economics. Okay, a bit more focus on this. So what does competition policy do? Well, mainly it looks at three main areas. So first of all, firms that compete with each other, that are supposed to compete with each other, should not make price agreements or other agreements. So that's the price fixing part. If you want to merge with another firm in your industry, then antitrust authorities will try to make sure that that doesn't lead to a dominant position. You don't become too big. So that is part of merger policy. And indeed, if you are a monopoly, if you have a dominant position, you should not abuse that position. More on that later in this course. So first, price fixing. Well, you cannot make agreements, explicit agreements with your competitor to fix prices. Implicit collusion, so you don't actually make agreements, but it turns out that you both set a high price. That is not strictly speaking illegal, but we'll get back to that when we discuss collusion in a couple of weeks. There are also leniency programs in place. So if you are part of a cartel, but you go to the competition policy authority and you spill the beans and you agree, you admit that you are part of this conspiracy and you also give the proofs, then your fine will be much lower than that of your co-conspirators that didn't come forward. Let me not go into this. So merger policy, what often happens. So if you want to merge and you are big enough, you have to notify the competition authority. They will look at the market definition. So what is the relevant market? And do you get a big position, a big part of that relevant market? And that is often a very important issue, the market definition. For example, if Pepsi would want to merge with Coca-Cola, then what is the relevant market? Is it the market for cola or the market of anything that people drink? And of course, firms that want to merge try to make that market as broad as possible. However, whenever the relevant market has been established, then usually as a first screening, we're going to look at the Hirschman-Herfindahl indices. So what would this mean for the HHI? And if it's really going to increase, we may have to have a further look, and if not, then not. But again, many more details in the book or in the course Competition Policy. So after this rather lengthy introduction, this is the first proper topic of today, if you like, and that is price discrimination. Okay, so To give you a bit of the background, let's go back again to the first year course in microeconomics. Um, this is a slide that I used when I was still teaching that course. So let me talk you through it. So suppose that I have a bakery at the Seneca complex, and that bakery is a local monopolist. So I can just decide which prices I'm going to set. I don't have to worry about any competitors. Okay, and suppose that, well, I face a downward sloping demand function, of course. Uh, and that is such that if I would sell 100 loaves of bread, then I could charge a price of €2. But of course, if I want to sell more, if I want to sell 101 loaves of bread, for example, I have to charge 199 to make sure that people really want to buy 101 rather than 100 loaves of bread. Okay, so if I want to sell one more loaf of bread, what would be my marginal revenue? Well, to sell 101 loaves of bread, I need a price of 199. If I want to sell 100, I can set a price of 2. So the difference between these two revenues would be my marginal revenue, right? That's 0.99 in this case. But that implies that I will not make that extra sale if my marginal costs are 1. After all, my marginal revenue would be lower than my marginal cost, which implies that making that last sale is not just worthwhile to me. The additional costs do not outweigh the additional revenue. Whereas, of course, from a welfare perspective, it would be good if I would make that sale, because from a welfare perspective, well, there's somebody willing to pay 199 for the additional loaf of bread, and it only costs €1 to produce it. So from a welfare perspective, it's definitely socially efficient if we would make that extra loaf of bread. People are willing to pay more for it than it costs to produce it. And so what is sort of the crucial reason why it's not worthwhile for the monopolist to do that? Well, for the monopolist, if it wants to sell this additional loaf of bread, it has to lower its price, but that implies that the price will also be lower for the first 100 people. If I lower my price to 199, then this additional person wants to buy this loaf of bread. But all the other people now also pay 1 cent less. And that is exactly the reason why my revenue increased by much less than 199, right? Um, so to sell more, I have to charge a lower price, not only to the additional guy, but also to all others. So that causes this problem of inefficiency. Okay, but what if that is not true? So, first of all, this is how you first year book uh, explain that, and that boils down to the same thing I did on the previous slide, right? If you want to increase your sales from Q1 to Q2, then this will be your additional revenue from selling more stuff. But in order to get those extra sales, you have to lower your price from P1 to P2. So you lose some revenue here from the people that were already buying from you. And of course, that is no longer true if you can charge different prices to different consumers. Okay, so that is price discrimination. So price discrimination means that a seller sells the same product to different buyers at different prices. Or to relax that definition a little bit, it sells similar products, but the price difference is not only due to a difference in cost. And I will show you later cases in which that becomes clear. And if you think about it, this really happens very often. So if you buy an airline ticket, then the price that you have to pay will depend, even if it's the same flight at the same date and the same people on board, then the price that you have to pay will depend on when you buy the ticket. It also depends, of course, whether you travel business class or tourist class. Um, Often you pay less if your stay includes a 7-day night. It depends on when, how, where you buy, etc. Um, so same product essentially, but different prices. In telecom, something similar is true, right? If you buy your mobile phone subscription, then how much you have to pay. Well, you can choose between different packages. You can choose between 5 GB, 10 GB, and usually the bigger your package, the lower the price per gigabyte. So also in that case, you get a quantity discount, but that means that for the same product, you pay a lower price. Trains are a good example as well. If you go by train, and if you go online to the NS app in advance, then you may get a better price. If you travel in off-peak periods, if you are an elderly citizen, you will get a senior citizen discount. There's first and second class. They are not exactly identical, but the price difference between those two is much bigger than the cost difference for the railway company. So that's where that definition kicks in. Um, but again, when you travel, how you travel, whether you're a student, whether you're a senior citizen, whether you have a yearly travel card, etc., all that affects the price that you pay for your train ticket. Quantity discounts are already discussed, and another example on your electricity is your electricity bill, where you pay a fixed fee to get access, and then you pay a price per unit for the electricity that you actually use. So also that would be price discrimination, since how much you pay per unit depends on how much you use. There are quantity discounts involved. And online, there's a lot of price discrimination going on, often referred to as dynamic pricing there. And I will give you a couple of examples for that as well. Okay, so here's an example of flights. So this is already pretty old, but it's a very neat illustration of what happens. So here you see two curves. One is for domestic tickets within the US. So if you want to fly from Florida to California, say. And here are the prices for international tickets. And what you see on the horizontal axis is the time before the flight actually takes place. So this is almost 1 year before the flight on the one end of the graph, and this is on the same day, essentially, on the other end of the graph. So what you see in both cases is that if you buy your ticket well in advance, then you pay a relatively high price, because probably the airline company figures, well, if you are so risk averse or desperate to already get your ticket well in advance, then you likely are also willing to pay a bit extra. And then the price lowers as the time of flight is getting closer, but sort of starting roughly 2 months in advance, prices start to go up and up. And if you book a ticket 1 or 2 weeks in advance, then you really pay a huge amount of money. Apparently, the airline company figures, well, if you definitely want to travel tomorrow, then probably you're either very desperate or you're a businessman, and prices don't really matter to you. So we can charge you a much higher price. And patterns like this, you can see that in many other industries as well, of course. So here's also an interesting example. If you would go to Amazon, then to buy the exact same product, in this case, a Sony WH-1000XM4 wireless headphones with noise canceling, um, those prices also fluctuate pretty much from one day to the other. So if you go to www.camel.com, I have no clue why, then you can just check your favorite products and see how the price has fluctuated over time, and that may allow you to buy at a or to or at least to get an idea whether the current price is low or high, or whether it may be worthwhile to wait a little longer for prices to come down. And talking about Amazon, another interesting thing is, of course, that Amazon is active in many different countries in the European Union, but also charges different prices in those countries. So if we are in Europe and we want to buy those exact same headphones, then if you go to Hagelson.com, then you can see in which country you should buy your headphones. So that's a free money saving tip already. For example, that exact same headphone, if you order it from Spain, you only pay 205 euros. Whereas if you are located in France, you would pay almost 100 euro extra. So, well, within the EU, we have a free um, movement of products. So if whenever you want to buy this headphone, you're definitely best off ordering it from Amazon Spain rather than any of the other Amazons listed here. So do go there before buying your stuff. Here's an example of dynamic pricing that was an issue, especially last year, especially with concerts. It's often an issue as well. And last year, the CMA, which is the antitrust authority in the UK, launched an investigation into Ticketmaster over Oasis concert sales. People were standing in line and turned out that they had to pay much more than they were originally promised. So that is referred to as dynamic pricing. The price that you pay depends on exactly when you buy and how many people have bought already. Okay, so there are a couple of types of price discrimination, maybe already clear from the discussion so far. And rather unimaginatively, they're referred to as first, second, and third degree price discrimination. So these are probably on my notes. Really, so let me explain a bit more detail. So first degree price discrimination, that is sort of a theoretical ideal. So first degree price discrimination simply means that you charge to every person exactly what that person would be willing to pay. And of course, the problem is that you never know exactly what somebody would be willing to pay. For that reason, it's a theoretical extreme. But of course, the reason that all the websites keep tracking you and keep putting those cookies on your web browser is exactly to try to find out as well as possible um, how much you would be willing to pay. Amazon hires dozens of PhD economists every year to sort of try to figure out what is the optimal price they could charge you and how they could tweak that algorithm. Okay, then we have third degree price discrimination. Let me discuss that first because that's a little easier to explain than the second degree one. Also referred to as price discrimination by indicators. So in that case, there are a couple of different groups in society, and the monopolist or the firm can distinguish between those different groups and charge them different prices. So, for example, back to my train or bus, if you like, there are some people that are older than 65, senior citizens. I can clearly identify them. I can just ask them to show their ID or whatever. And then I can just charge them a lower price than I charge to the less senior people below 65 years of age. Why would I want to do that? Get back to that later. What is important, of course, is that we can avoid arbitrage. So arbitrage would be a case in which somebody else can just do the buying and can sell it on to somebody else who is not entitled to the low price. Bit more concrete, buses often give a discount to senior citizens, but bakeries don't. Because if bakeries would offer a senior citizen discount, then I would just send my grandmother to the bakery and let her buy my bread. So that would be an example of arbitrage. Then the last option and the most interesting option, we will also get back to that, is second degree price discrimination by self-selection. So in that case, there are these different groups of consumers out there. Some are willing to pay a bit less. Some are only willing to pay a bit more, other way around, whatever, you get the idea. Um, but I'm not able to really distinguish between those two groups. Or I am able, but I'm not allowed to charge prices based on that. So in that case, I could try to design my products in such a way that people are going to self-select, that people are going to reveal themselves by the choices that they're going to make. Okay, that still sounds very vague, but I will give many examples later in which that becomes more clear. So, three types of price discrimination. So here are a couple of examples. Senior discounts, you have to prove your age to get the senior price, so that will be second degree, right? Student discounts, same story. To get the discount, you have to prove that you're a student, so that will be second degree price discrimination. But then business class. Well, if you want to fly, you can choose business class or tourist class. But, well, the airline company cannot really distinguish between those two groups. It cannot say, well, you're a businessman, so you have to pay more. But what it can do is design the products, design the different classes in such a way that business people voluntarily choose to fly business class and pay a bit more. So that will be second degree price discrimination. And again, I will be more elaborate on that later. Mobile phone, similar story, also second degree. There are heavy users, there are light users. So what I can do is to design my bundles in such a way that everyone chooses what's best for them and thereby reveal their type. So there you have it, third degree, second degree, and second degree. Okay, so a bit more detail. Here's first degree price discrimination. So suppose that this is your downward sloping demand function, and suppose you're able to charge everyone exactly what they're willing to pay. So this person here, we're able to charge them that price. That person here is willing to pay this amount, and you're able to charge that. So what happens in that case? Well, then my firm, back to my bakery, if the firm is able to do that, it will charge everybody exactly their willingness to pay. And it also means that it's going willing to supply up to marginal cost, right? If my willingness to pay is slightly higher than marginal cost, this monopolist is still willing to provide me with bread, and it will be willing to do so for everyone who has a willingness to pay higher or equal to marginal cost. And interesting thing to note, that would imply that this monopolist would end up at a socially optimal outcome, right? Because prices will, everybody who is willing to pay more than marginal cost will end up buying the thing, and that is socially efficient. The only difference, of course, with perfect competition is that all the surplus now ends up at the bakery. These will be the profits of the bakery, and consumer surplus will be zero since everybody pays exactly what they are willing to pay. So let's now look at third degree price discrimination in a bit more detail. So, as I mentioned already, the firm can distinguish between groups and is allowed to separate them. And as my leading example, let me look at a senior citizen discount. Senior citizens pay a lower price on the bus, and let's analyze that case. Okay, so suppose that you operate a bus company and you face two types of consumers. There are senior citizens, which we denote as S, and there are other citizens denoted as O. Each has their own demand function. This is demand from senior citizens, and this is demand from other citizens. So if we plot that, then those demand functions look like this. So as you can see, the other citizens, it's a bit steeper. Senior citizens have a flatter demand function. Okay, we need, so here are my demand functions again. Let's put some additional numbers. So suppose that marginal cost are constant and equal to 10. And then the question is, of course, what would be the profit maximizing price? Okay, so we will start with a case without price discrimination. And that implies that we just charge one price for everyone. So to find the profit maximizing price, we first need to derive total demand, right? So to do that, of course, total demand equals demand from one group plus demand from the other group. But I now have demand functions that look like this. So these are actual inverse demand functions. So it doesn't make sense to add prices, of course. So before I can derive total demand, I first have to rewrite my demand functions per group in terms of quantities. So that's what I do here. And then my total demand will simply be the sum of these two demand functions, right? So that gives me this total demand. But this only holds for low prices, right? Because for higher prices, we only have demand from the other citizens. Let me go back to my demand functions. So whenever price is here, then I have demand from the senior citizens and from the other citizens, and my total demand is just the sum of those two. However, if demand is higher than that, if demand is in this area, then my senior citizens don't have any demand, they have zero demand. So all the demand comes from my other citizens. Okay, so here I have my original demand functions. So what is total demand? Here from this point onwards, let me add the demand from senior citizens to that from ordinary citizens. And then this, the red line, is my total demand, right? So it has a kink above this choke price. I have demand from only the other citizens. Below that price, I have demand from both citizens. Okay, so how am I going to solve this? How am I going to derive my profit maximizing price? Well, I'm just going to maximize profits on the joint part of the demand function. Then I have to check whether the quantity that yields is indeed such that both groups have positive demand. If that is the case, then this is the true profit maximizing quantity. And if not, I have to restrict myself to high demand consumers. Okay, let me just go through this. That will probably become a lot clearer if I just do the analysis. Okay, first I need inverse demand. This is my total demand that I derived on the previous slide. So if I again rewrite that in terms of P, then this is my inverse demand. Why would I want to do that? Well, I want to know the quantity that maximizes my profits, right? So I need the Q that maximizes my profits. So that means that I have to write my demand also in terms of Q. So if I do that, this is going to be my profits. Remember that marginal costs are constant equal to 10. So for every unit that I sell, I will have cost of 10Q. And so this will be my total profit. Maximize this. I assume you know how to do that. Gives me this quantity. If I plug that back into my inverse demand function, I get a price of 35. And then if I plug those numbers, if I plug my Q back into my profit function, I get profits of 31.25 over 2. Make sure you know how to do that, otherwise in the tutorial. So at that price, if I plug that price back into my two individual demand functions, then demand from senior citizens is 30 and demand from other citizens is 65 over 2. So both are positive, so this is really my profit maximizing price. In other words, in mathematical terms, this is feasible. Back to my graph. Marginal costs equal to 10, that's here. This is my monopoly price, 35. So I can also see here the demand from the two individual groups. Okay. To see what I meant with these two groups, etc., it's useful to analyze the case where marginal costs are equal to 45. So then my profits would look like this. If I maximize that, I get these quantities and plug that back into my demand function. I get this price. But at that price, if I plug that again into the individual demand functions of the two groups, I would get a QO of the citizens of 95 over 4, but a QS of -5. And of course, that doesn't make sense. In other words, that's not feasible. So if I assume that I have demand from both groups, I end up with a nonsensical price, a price with negative demands. So that simply implies that if I maximize my profits, I am only going to cater to the other citizens. It is profit maximizing to only serve the other consumers. So I will only take their inverse demand, and then it turns out that this is going to be my profit maximizing quantity. This will be my profit maximizing price. At that price, zero demand from senior citizens and a positive demand from citizens. So if I also do that in the graph, if these are my marginal costs, then this is what I get if I take both of the demand functions together. But that doesn't make sense because then I would have negative demand from the senior citizens. So at that price, there is no demand from S. So we should be on the more vertical part of the demand function. And this is the profit maximizing. Take that into account. Okay. That was just an aside. So let's go back to the original situation. So again, my marginal cost at 10, and I already figured out that This will be my profit maximizing price, and these will be my profits. So this is if I just charge the same price to both groups. No price discrimination. Okay, but what would happen if I can price discriminate? What if I can separate both markets? For example, I can ask senior citizens for the senior citizen card, and I charge a different price for both types of consumers. Okay, then the analysis actually becomes a bit easier because I can just look on the two submarkets separately and maximize my profits on each. So let me first look at the senior citizen market. So these are my profits on the senior citizen market. Again, taking this inverse demand function, maximize that, you get a quantity of 40, a price of 30, and profits of 800. What about the other citizens? Same story. Take their demand function, maximize profits on that market. That will give you a price of 55 and profits of 2025 over 2. How does this compare to what I had before? Well, my profits now equal 3625 over 2, which is much more than what I had before, right? This is higher than 3125 over 2. So in this case, it is indeed profit maximizing to charge different prices to these two groups. Look at the graph again. So this is the price with price discrimination for the senior citizens. This is for the other citizens. So what I get in this case is a senior citizen discount. So why do I get that? So the reason that senior citizens pay a lower price is not necessarily because of the goodness of the bus company, but simply because it's profit maximizing to do so, right? At least in this case. Um, and it also means that, well, if I compare the cases without price discrimination, this would be the price. What happens with price discrimination? Well, the senior citizens get a lower price, but the other citizens get a much higher price. So that's what I mentioned here. So it makes the senior citizens better off, but it makes the others worse off. Um, by construction, it also has to make the monopolist better off. It's easy to see why the monopolist can charge different prices to the two firms, but it doesn't have to, right? Even if it price discriminates, it can always charge the same price to both groups. The fact that it doesn't simply must imply that it is profit maximizing to do so. Another thing to note is that, well, this condition is familiar, hopefully, from your first year course. So there we noted that your profit maximizing price is a monopoly, the profit maximizing price cost margin, if you like, equals 1 over the elasticity of demand. So that was your learner index. Um, and with price discrimination, that simply holds in each market separately. So consumers with high elasticity of demand get a lower price, and those with low elasticity of demand get a higher price. So why do senior citizens get a lower price? Simply because they are more price sensitive, right? So they have lots of other options to do with their time. They take the bus to Winkel Center in Paddepoel, for example. But well, if prices increase, they're probably going to do something else. Whereas the other citizens often have to take the bus to go to work or whatever. So they are much less price sensitive and as a result get charged a higher price. I also already mentioned this before. This can work for bus tickets, but not for bread. In other words, we need that there is no arbitrage. Arbitrage should not be possible. We're economists, so we're ultimately interested in welfare effects. Okay, so here is what we get with linear demand. So a necessary condition for this type of price discrimination to increase welfare is that it increases total output. So welfare only goes up if total output goes up. That is never the case with linear demand. So with linear demand, it decreases welfare. There's one important example that exception, sorry, is that is only true if the same markets are served with and without price discrimination. So in other words, it may still increase welfare, but it can only increase welfare if it opens up new markets. This is also something that will come along in this week's tutorials. So indeed, if without price discrimination, I would set a price so high that senior citizens would not travel, then if price discrimination results in senior citizens also taking the bus, then in that case, but only in that case, price discrimination, third degree price discrimination, increases welfare. Finally, let's look at second degree price discrimination. So, as I mentioned already, that is the case if a firm faces two groups, but it cannot tell who belongs to which group, or at least it cannot base its prices on that. It is no card it can ask for, or maybe it's simply not allowed to base its prices on whatever information it can observe. So, for example, some consumers are willing to pay a lot for high quality, and some other consumers are willing to pay far less. But also, then there may be a possibility to price discriminate. Okay. How does that work? Well, the firm may induce consumers to self-select. And as an example, let's take the first and second class on the train. Also, this is referred to as versioning. So you design product lines that appeal to different consumers. Sellers cannot directly identify consumer types, but it can still induce consumers to distinguish themselves. That will be the essence of what I'm going to tell you. So let's go to a classic example, which is a railway company. The monopoly wants to maximize profits, and it offers first class and second class seats. There are two types of consumers, those with a higher willingness to pay and those with a low willingness to pay. And we assume, for simplicity, that those groups are equally sized. And to make matters simple, let me refer to them as the rich and the poor. So the rich have a higher willingness to pay, the poor a lower willingness to pay. And let me also put some numbers on this. So for second class, the poor are willing to pay 6, the rich 8, whereas for first class, the poor are willing to pay 10, and the rich are willing to pay 19. Marginal cost, of course, is a bit higher for first class, so let me assume that it is 1 and 2, respectively. So here is a table that neatly sums up all this information. Okay, so the easiest way forward is to first assume that there is complete information. So, in other words, suppose that the railroad company can perfectly observe who is rich and who is poor. Um, and it is also allowed to base its prices on that. So there are a couple of options. It can choose to sell first class tickets to the rich. In that case, it will charge a price of 19 because that is what they would be willing to pay. Its profits from the rich would be 17. If it sells second class to the rich, it will charge a price of 8 and profit will be 7. For the poor, a similar analysis holds. It can sell first class to the poor. They're willing to pay 10, so its profit will be 8. If it sells second class, can set a price of 6, profits would be 5. So in this case, it turns out to be profit maximizing to offer first class tickets to both, but charge 10 to the poor and 19 to the rich. And in that case, your profit will be 25 multiplied by the number of people, of course. So this would boil down to perfect price discrimination, right? I can observe who is rich, who is poor. I can adapt my prices to that. Okay, let's go for the more interesting scenario. Suppose that the railroad cannot observe who is rich and who is poor, or it is simply not allowed to charge people different prices based on that information. Okay, now we have to be a bit more precise. So it has a number of options. It can only offer first class, it can only offer second class, or it can offer both first and second class, but try to tweak prices such that the rich travel first and the poor travel second. Okay, what is the best thing to do? To find out, we simply have to go through all these options. That's my table. So, okay, if I offer only first class, I can make sure that the rich are willing to do that, willing to travel that way. That would involve charging a price of 19. My profits would be 17. But I can also set a price equal to 10. In that case, also the poor would be willing to travel. I would earn 8 on each customer group. There are two groups equally sized. So my profits would be 16. Okay, so if I only offer first class, I would charge a price of 19 and only sell to the rich, because then my profits are high. What if I only offer second class? Same logic. If I only sell to the rich, I can charge a price of 10. My profits, sorry, a price of 8. That's this entry. Profits will be 7. If I sell to both, I could charge a price of 6. Profits would be 10. So if I would only offer second class, then I would charge a price of 6, make both people buy, but still the option to offer only first class and charge a high price for that gives me way higher profits. So that gives me that bullet point. If these were my only options, I would offer first class at a price that the poor cannot afford. Okay. But now suppose that I can do second degree price discrimination. So the idea is as follows. I'm going to offer both first and second class, and I try to make sure that the rich travel first and the poor travel second class. Okay, let's figure out how to do that. I want the poor to travel second class. So that means that I cannot charge them a price higher than 6. So this is going to be the first constraint. I have to set P2, the price of second class, smaller than or equal to 6. That is a participation constraint. Second, I have to make sure that the rich want to travel. I want them to travel first class. They're willing to pay 19 for that. So P1 has to be smaller than or equal to 19. Another participation constraint now for the rich. But more interestingly, I also have to make sure that the rich prefer first class over second class. What do they get if they travel first class? They get 19, but they have to pay a price of P1. So this is their net utility, their net benefit, their surplus if they travel first class. What if they travel second class? Well, the rich are willing to pay 8 for second class. If they have to pay P2, this would be their surplus. So in other words, the rich prefer first class whenever this is satisfied. And that equality is a bit of a knife edge case, of course. Usually we assume that, well, you could all, to make sure that they travel first class, you could also always decrease P1 by a infinitesimally small number. But for simplicity, we always ignore that. And we just assume that, well, whenever consumers are indifferent, we just assume that they do what we want them to do, essentially, to avoid always having these discussions of setting a price just epsilon. Anyway, to make sure that the rich prefer first class, I have to make sure that this is true. This is my incentive compatibility constant. Also make sure that the poor prefers second over first, but that is always satisfied, so let me ignore that. Okay, so these are my conditions. So I want prices as high as possible, of course, but I have to make sure that these constraints are satisfied. Okay, so the first thing to do would be to set P2 as high as possible, right? If I set P2 high, then this only becomes easier to satisfy, and so that means that I can set P2 as high as 6. This never violates the other constraints. So let me do that. So then the other constraints simplify to P1 smaller than 19, that was this one. And if I plug in a price P2 equal to 6 here, and I rewrite it a little bit, I get P1 smaller than or equal to 17. Okay, so P1 has to satisfy these two constraints, so obviously I want to set it as high as possible such that both are satisfied. So I have to set P1, there's the one missing here, P1 equal to 17. What are my profits in this case? By setting these prices, I make sure that the poor travel second, the rich travel first class. These are the profits on the poor, these are the profits on the rich. Gives me total profits of 20. And that is interesting because before the previous slide, I had profits of, there they are. My highest option so far was 17. So what I do now actually gives me higher profit. So that is the profit maximizing package. These are the profit maximizing packages in this case. So this is my best option. Some interesting things. Well, the poor in this case end up paying what they're willing to pay. So they get zero surplus. In the literature, that is known as no surplus at the bottom. What about the rich? Well, the rich, they do get a positive surplus, right? They are willing to pay 19 for first class, but they only have to pay 17. Why? Well, because if I charge them a higher price, they would travel second class instead, and I don't want that because then my profit would be way low. So they get a surplus of 2. Why? Because I cannot really distinguish between rich and poor, so that is known as an informational rent. And they get it as the railway cannot observe the type, as I mentioned already. It also implies that profits are lower than if first-degree price discrimination were possible. Yes, in my complete information analysis, profits were even higher because then I didn't have to pay this informational rent to the rich. And indeed, what drives the price of the rich is that they should prefer third over second. Okay, you can actually take this analysis a bit further. That's where things get really interesting. Suppose that the railway, for whatever reason, in whatever way, would be able to lower the quality of second class. And it can do so in such a way that the new willingnesses to pay would be a bit lower. It can get rid of toilets or whatever, make it less comfortable. And then willingness to pay will also go down. In this case, would it be willing to do that? So this was the original situation, but now this is the new situation. Okay, let's see how that affects the analysis. So These are my new constraints. P2 has to be smaller than or equal to 5.5. If I want the low to travel, P1 again has to be smaller than or equal to 19 if I want the rich to travel first class. But my incentive compatibility constraint is now going to look like this. 19 minus P1, the surplus from the rich if they travel first class, should now be bigger than 6.5 minus P2, which is their surplus if they travel second class. Can rewrite it a little bit. So I'm now going to charge P2 equal to 5.5 and P1 will be 18, which is higher than the 17 I had before, right? Why? Well, what drives this price is the fact that I want to avoid that the rich are traveling second class. And it's now easier to avoid that since second class has now become more lousy. So what are my new profits? My new profits from the poor plus profits from the rich are 20.5, which is higher than the 20 I had before. So in other words, by making the lower class, the second class, worse, I can increase my profits. I explained this already. It relaxes the incentive compatibility constraint of the rich in technical terms. We can charge them a higher price. They are less tempted to travel second class. And if you would do a full analysis beyond the scope of this course, you can show that indeed the quality for the poor will always be lower than the socially optimal. So that dates back to this whole analysis dates back to Dupuy, a French railroad economist in 1849 already. And he did this analysis purely verbal without any math whatsoever. But his main conclusion, which is a very neat quote, is that, well, what the railroad company is trying to do is to prevent the passengers who can pay first class from traveling second class. It hits the poor. The poor are now worse off. They get lower quality, although the surplus is zero. Not because it wants to hurt them, but to frighten the rich, right? And that's indeed exactly what's going on. So the next time you travel by airplane and you're thinking, why do I get these lousy leg space and this lousy quality? Well, it's not to hurt you, but it's to keep the rich people from traveling tourist class, right? Okay, that's all we have for this week. We will see you starting Monday at the tutorials and the next live lecture Wednesday at 3. See you then.